10 factorial, sorry, n is equal to 10, r is equal to 3, n factorial divided by 10 minus 3 factorial. I'll go away on this one. So I won't write all at the top. All I need to write is 10 times 9 times 8. The rest of them are all cancelled. 8, 9, 72. 72 means 720 different combinations. The 10 minus 3, 10 minus 3 takes care of the rest. Okay. So I have 7, okay? I got somebody looking like that. I got someone looking like what I got on the board.
Yeah, you want the stream up, right?
Oh, wow. Oh, good. I'm on live. Okay, good.
Then that works.
All right, Joliet, I hope you can hear me. If you have any questions, feel free to call Mike Ogler. He is ready with his cell phone. All right? Sorry for this. You missed few, but not a lot, and I can make up after the class. If you want, I can talk to you on one-on-one. Thank you. You guys are watching me or taping me. Last time you did a number on me. When I went there, everybody was laughing. You're not going to do that today, right?
No.
Okay, good.
I promise.
All right, go. You promised, right?
I promise.
Okay, go. All right, shall we move to the next one? I know they told me I was very well audible, but scribbling was this thing. So I may have to go back to overhead. Company XYZ wants to randomly select a committee of 3 people out of 15-person engineering section. Sorry, 5-person. After 5-person engineering section, Diane is one of the 5 people. Diane is one of the 5. What is the probability that Diane will be on the committee? Diane will be on the committee. So the question is, let's take a pause a little bit. I have what? There's a total of 5, and the committee consists of only 3. So we have to look at what are the total combinations that you can form with 3 on a committee. Out of 5, selecting 3, correct? So that is the number of combinations you have. Then we have to look at, you have to take away Diane and see how many combinations we get. If there are, in the beginning, we have 5, take 3, right? Get that number. Then from 5, take away Diane, that gives us a group of 4, right? But still I have to form a committee of 3. So compute this number, take those 2 numbers, subtract one from the other. The committee now will definitely have Diane. I have, one more time, we have 5 total available, and we can form a committee with 3. No discrimination. Diane in and out, we don't. So these are the number of combinations we have, permutations we have. These are so many different ways I can form, which includes Diane, may not include. That's the combination. From this, I have to select in how many ways Diane cannot be there. So I'll take a 5, reduce it to 4, again form a committee of 3 with 4, and I get a number. Subtract the 2 numbers, I can guarantee you that many times she will be there. So since we got a friend on the online, this one I may do something on the board, but right now this is a little longer one. Let me share with you the solution. You have what? You have a n, where is this guy? Okay. I hope you can see my cursor. You have a combination n comma r is n factorial over r factorial times n minus r factorial. Okay, n is 5, r is 3. So I get, how many combinations do I get? I get Out of 5, I want to form a committee of 3. I can form a total of 10 different combinations. I can form 10 different combinations. Then I'm going to say Diana is not going to be a part of this selection process. So she's out. Once she's out, I have a total of 4 left, and still I'm going to form a committee of 3. So it's a combination of 4 comma 3, 4 factorial over n factorial over r factorial times n minus r factorial. 4 minus 3 factorial is how much? 1 factorial. Ready? Factorial 1 is how much? How about if I want to take, and there was a Jack also in this group. Ready? I want to ask you this one. There's a Jack also. Now I'm going to take out Diane as well as Jack. That leaves me what? N will be how much in that case? 3. And what will be this one? 3 minus 3 is 0. 0 factorial is what? 1. 1. Okay. Alright, so let's not deviate too much. If you can digest this simple, if you can take this, that should be enough. So basically we look at the total combinations are 10. Without Diane there are 4. That means I can guarantee you there will be 6 combinations left over in which Diane will be part of it. Okay. 6. So do I have 6? So I go back. No, I'll wait a few seconds. And what are my options? What are the? And if you think more carefully, it's back. Okay. We go back here. Now you have 60% number C. Letter C would be your response. Letter C would be your response. Okay. These 2 examples should be enough to get you rolling into the exam. That should not be should not too much bog you down. Okay. Let's move away to the next problem. Can I? Everyone? Uh-oh. Yeah. Let's take the calculator and let's calculate this one. What is the average height and standard deviation of adult American men based on the following sample? There were people ranging from 61 to 80 inches tall, and there were 10 of them measured. And what is the average height? So go ahead, add all those numbers on your calculators and divide by 10, get me a mean. Everyone has a calculator, quickly add that up and find me a mean. Then I will ask you to calculate the standard deviation. If you were to do this at this time, you can do it any other time. There are functions on the calculator itself, and in fact, if you put these numbers, you can, it will give you a mean. It will also give you a standard deviation, but let's calculate this. You know what? You can even try to cheat a little bit, but he's trying to make it life a little bit difficult. Look, I can cheat a little bit. Once I know my mean, correct, if I do it correctly, add 10 numbers, divide by 10. You don't even have to divide by 10 because add the numbers and then that number, move the decimal. And you can select. But here he has 2 of them starting with the same number, 2 of them starting. So out of the 4, you can easily throw away 2. You can easily throw away 2. And look how close he is, 5.6, 5.6. When I used to write my it's still the case. Gentlemen, remember, PE exam, multiple choice, every alternative is obtainable. It's very easy to calculate, write a question and get an answer. Then the difficult part is come up with the alternatives thinking what the students would calculate and get a number. It's like a magnet. These alternatives, the four others are like magnet. You twist a little bit and you get the same number. Let me give you a simple example. What is the deflection of a cantilever? PL cube over 3EI, right? Most of the time they don't write PEI. So you have a number, you get the same one, instead of dividing with 3, get the number. So correct number multiplied by 3 will be a number there, and I is considered many a time with a circle, pi d4 over 64, many a time they write it pi d4 or 32. That's another way to compute it and write another alternative. So most of these alternatives are obtainable by making minor mistakes. What you first sit down, write a question, then the biggest tough part is to think what could be the student thinking wrong and write one and get a number that is obtainable. It's not a random number. This one's SME, a majority of them are random numbers, just trying to twist it. So where are we on this one? Do we have a mean? 68 or 70? Huh? 70? And then what's the standard deviation? How do you do standard deviation? What is standard deviation? Let me share it with you. Gentlemen? 70 root of S is equal to, remember this is n minus 1, it's a small sample, xi square minus x bar. What is x bar here? The mean. X bar is 70 n divided by this one. So basically you're going to continue this process, summation of it, 61 square plus 72 square plus 80 square minus n is going to be 10 times 70 square, all divided by 10 minus 1, comes out to be 5.9. Comes out to be 5.9. Is it too much taxing after a long day? Remember, today's one, you are good for a lot. Process of elimination, you can, I expect you, if you don't remember this, okay, fine. But you must be able to get the mean. Why I'm saying is, once you get the mean, at least in this particular case, you eliminated 2 of them, your chances of success are straight 50%. Close your eyes, toss the coin, and you are 50% of the time correct. So always try to improve your chances of getting to the right answer. Yes, I don't know the standard deviation equation, fair enough. But I can find the mean. Okay? All right. Go to the next one. A rolling operation produces parts that are normally distributed with a mean thickness of, I'm going to solve it on the board, don't worry. Mean thickness of 0.22. All right, mean is mu. Let's go here. Let's go here. Let's digest this up. It's good for you. Many of you are from industry. It's good for you to get a feel for what's happening here. And yeah, we want to pass the exam. Sure, we want to pass the exam. That's our goal. But in the process, we'll also gain something to take with us. So what do I have here? I'm rolling sheets and the mean thickness, mu, is equal to 0.220 inches. Okay? Then it's also telling me the standard deviation is sigma is equal to 0.022 inches. 0.002 inches. Okay? 0.002 inches. If the specification calls for a thickness of, what is specification, Norman? Do we know? I know many of us, if you are too much into manufacturing, you might get a little bit confused with designer is one and process is another thing. The designer says, I want a shaft 1 inch in diameter. The manufacturing engineer says, I can make 1 inch. Give me some room. So the designer says, okay, I will leave it 1.01 or 0.99 inches in diameter. Now that 1.01 is your upper specification limit, it's a number given by the designer, And then 0.99 is a so-called lower specification limit, again given by the designer. It has nothing to do with that manufacturing engineer. You are all designers, they are all manufacturing engineers. Okay? So the designer specifies those numbers. USL, upper specification limit, lower specification limit, and what is 1? 1 is called the nominal. That's again defined by the designer. The manufacturing engineer goes, he sets up his lathe, takes the rod, feeds it, turns it, he produces it, gauges it. Oh, it's 1.001. That's the number he got. It's in between the two numbers specified, good, pass. If it is 1.2, he throws it off. It's not within the prescribed limit by the designers. Okay. So let's understand what we are talking about here is this guy is selling the process mean is 0.22 sigma standard deviation of the process. This is coming from the shop floor. The designer is telling the upper specification limit U is the specification limit is nominal, n is equal to 0.225. That's the nominal value, plus minus. I'll put this number here, 0.000. Wow, he gives a unilateral. Most often it's a bilateral equal number, plus minus. This is a unilateral, fair enough. 0.008 inches minus side. So what is it selling? Upper value is USL is equal to 0.225. Can anyone tell me what is LSL? Is equal to point what? 21? How much?
7.
That's my limits. What percentage of the parts will be acceptable? Okay, just a little bit more, but it's fun. Nice fun, nice fun. Do we have normal tables with us? No. Your book should have it, right?
The book has it.
There's the book. Okay, please, I'll project it at the top. Give me the book. You're supposed to come with a calculator and look, my friend. Run. Come back, quick. Anybody
Wikipedia
have a
has
book?
it too.
Give me normal tables. Give me normal tables, or at least I'll show you a little bit. I don't have, I wish I'd pulled it up, but. Joliet, if you have a normal table, go pull it out meanwhile. We are trying to get normal tables here. You have one mic with you? Normal
No,
table?
I looked it up online.
Online? Okay.
Yeah, I got it. Here.
You got it? Normal tables, get it now to close it up, and then we can put this one. Wow, that's a fancy book. That's a fancy book. I'll get that one. While we get that one, otherwise I have one upstairs. I can easily get that one and show you. If this
Yeah.
Okay, got it. There you go. Next one. This might give me some trouble. This might give me some trouble, but that's all right. Let's see here. Yeah, I'm going to show you the left portion first and right portion next, and I'm not using the full real estate, so make your eyes a little bit unstrained, so I'm going to do a little bit helping. Oh, don't worry about the bottom one, I can continue to move. Let's see if I can use more, a little bit 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 more. Okay, this should be good enough for you to see this one. Yeah, I'm going to pull this guy. This is a standard normal table, alright? And we define Z as whatever the X value minus mean divided by sigma. We define Z value as, we calculate Z and go here, right? We calculate Z and go here. What is Z? I may have to, no, I don't want to write on this book, but yes, I can write it. Don't get scared. Yes, I can write it. Yes, I can write it. Gentlemen, we define Z. down. Z equal to x minus mean over sigma. We calculate the Z value, right? And in this case, we have what is he asking? Our question was, let me get back to this in a second. Let's go back, flip back to our question and understand our question. What are we trying to do? So he's telling us if the specification calls for a thickness of 0.225 inches, what percentage of the parts will be acceptable, right? So he's defining me upper and lower specification limits, but he also gives me the process mean and process standard deviation. So I'm lucky, I can see both of it, you can't, but I'm going to go back to my document reader, and if you look at here, my process mean is this one, 0.220, and my standard deviation is 0.002. Follow me? Got me? Then from my board, which I wrote it upper specification limit, where all of you can see is 0.225 is my upper specification limit. So that is will be in this place. I'm going to substitute 0.225. Follow me? This will be my upper Z. This is general equation. Go back here. Z upper is going to be X upper. Basically, I can say USL. Now let me write Z upper will be USL minus mean over sigma, and Z lower LSL minus mean over sigma. And truly, I should write it opposite, mean minus LSL over sigma. I should write it the opposite way, mean minus LSL, because this will turn out to be negative. I should write mean minus LSL, but the number is the thing I'm looking at. Okay. So what is the Z value? Upper one is this figure I want to show you here. Is telling me only all the white parts will be rejected. This one will be always accepted. And the second one, let's see if I can use the same graph. In the second one, not that much visible, so I can move this way. Very good. I can say I have my another graph which also goes something like that. This is my Z upper. Assume that is Z upper. This is my Z lower. So this is what is rejected from the lower side, and Z upper is this one. Everything from minus infinity to this one is the number that you're going to get here, and for this one minus infinity to Z lower. So if I subtract minus infinity to this one with minus infinity to Z lower, I'll be left with this guy, which is all good, the middle one. Okay, the middle one. So he's asking us what percentage of the parts will be acceptable. Also, I want you to know, if you have not used this normal table, the entire area under the curve is 1. Entire area under the curve is equal to 1. And then I get my fraction values for Z. What is the Z value for upper? What is the Z value for lower? So Z value for upper would be, I would calculate, let's go get a sheet here. For upper, I already got the numbers here. For upper will be, Z upper will be USL minus mean over sigma is going to be 0.225 minus mean Mean value is 0.220. Joliet, I hope you can hear me. This 0.225 is from the specification that were given to us. The upper tolerance was 0, the lower limit was 0.008, therefore we took away that's coming, but upper remains as 0.225 divided by sigma 0.002. And what do I get here? What do I get this? I get a number here. How much? 2 point, that's it?
2.5.
2.5? How can it be? 2.5, okay, I'll take it. 2.5? Do I have a second? Okay. Now I take this 2 point, that means all the parts from minus infinity to 2.5, how much is the area? So I go back to my Z table. I don't see a 2.5, 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 I don't see a 2.5. Okay, I'm out. I'll come back here. Down, 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 down. Finally, oh, I see a 2.5. Exact 2.5?
Yes.
If it is 2.501, I would go here or 02. If it's 2.5 straight, under, oh no, come back here, down. Because it's, see, almost. Good. Now, you can have all of this. I have 2.5 straight. That gives me the first number, 0.99, write this down, 0.9938. So we are telling out of 1, 0.9938 will be acceptable. All right? And the rest will be rejected, being over the size. There will be parts larger than 0.225. How many parts? 1 minus 0.9938. That means 0.0062 parts will be rejected for being above the specification limit. But he is not asking how many we are rejecting being above specification limit. He is saying how many are acceptable to me. So I throw away 0.0062 being over size. How many I am throwing away for being under the size? Under the size means under 0.217. So how do I calculate that? I would go back and calculate my lower z, and I need it here, my z lower is what? I have 0.217 minus 0.220 divided by 0.002, and what do I get? I get what? Negative 1.5. Right? I go back here, I don't have to go to the right page, and I look here, let's get back here, and I come back, come down, 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 all the way somewhere. Oh wow, I find a 1.5, and it's solid 1.5, it is not 1 minus 1.50603, 1, like that, nothing is there. So I have 1.5, the first number is 0.0559, 0.0559. So let me write both numbers. Z, this is, okay, 0.0559, I'll write it here. This is 0.0559. Okay, and the other one was 0.9938. Okay, Roman, this guy can go away. This is much better now. This gave us a Z value of 0.0559. 0.0559. The other one gave us 9938. This guy gave us 0.9938. All right. This tells us that we are going to throw away 0.062 pieces of oversize, and here this is telling us we're going to throw away for this much for being undersized. The rest is what? The gap between the two is acceptable. 0.9938 minus 0.0559. This will give me 9. This will give me 7. This will give me 3. And this will give me 9. So what is acceptable? I have, did I get this correct? 0.0. What was your minus 1.5 correct? 1 point.
I think you used the .009 in the chart instead of all the zeros.
0.009.
Yeah, you took the first one here instead
Oh,
of there.
oh, yeah. Good. Roman, look at this one.
Big of a deal.
Look at that. Careful. This is 0 to 09. Here it is 09 to 0. The value should be not here. Go all the way up. 0.0668. No, I'm out. Where am I? Come back here. 1.5. Am I visible? No, not yet. Not yet. Okay, there you go. The last number. The last number is bottom right corner. 0.0668. I needed to take minus 1.5. I took what? 0.0559. This corresponded to 09. This goes this way. 09 to 0. On this page, it goes from 0 to 09. Okay, little catch there. So the actual number for this one was 0.0668. 0.0668. This number should be 0.0668. So I have to redo this computation one more time. I'm going to do it here. 0.9938 minus 0.0668. That gives me 0. That gives me 7. That gives me 2. And that gives me 9.0. 0.9270 are acceptable. Let me give you a little bit more, so let's continue on this one. 0.0062 are rejected due to oversize. 0.668 are rejected due to undersize. All right. Total, if you add up all this together, this should be 1, 0, 6, 6, 12, 12, 19, 20, 2 carry, 8 plus 2, 10, 1 carry, 0, 1. Okay. 1. So we are telling that 0.927 are acceptable, 0.0062 are rejected due to oversize, and 0.668 are. So if you look at the graph, this is what it is. Oh, I'm not visible. Okay, the graph is this. This is, let's look at parts per million. Parts per million means I am saying 66. This is telling me parts per million. This is parts per million is 66.8K. 66.8 thousand I am rejecting due to undersize. This is rejection is 6,200 parts I am rejecting due to oversize, and I am accepting the good number of parts out of million are 92,700 are good. 60, no, 60, no, 9 million, right? So 3 zeros, 0. 927,000 are good. 6,200 are rejected due to oversize. 66,008 are rejected due to undersize. The rest is good. That is a million, parts per million, ppm point of view. Okay. And percentages point of view, I am rejecting 6.8% of being undersized, 0.62% being oversized, accepting 92.7%. Accepting 92.7%. And if I go and flick this guy, I'm accepting 92.7%, and lo and behold, one of them happens to be that one. Okay. So what is the takeaway from this? In a slow mode, the takeaway is you have something called process, something you have designed. The design specifications give you the nominal value and the upper and lower specification limits, which is always, oh, I can't write it, but I can, that man is there. Let's see here. No, back. Yeah. Better one. So we usually have process specification, upper specification limit, nominal, lower specification limit, LSL, and this is, let's say, nominal is 1 inch, 1.01, 0.99. This is a bilateral one, and mean, process mean is equal to a couple of quick things. It will go much later. I'm jumping the gun here. If process mean is equal to 1.00, your process is on target. If your process mean is equal to 1, or if process mean is equal to the nominal value, your process is on target. Okay. And in this case, you can calculate CP. It's coming up later, much later. And if your process mean is equal to, let's say, 0.987, you know it's not equal to the nominal value. This process is not on target. In this case, I have to find CPK. CP and CPK definitions vary depending on the day, town, and place. So we will establish one concept of CPK and go there. But right now, so this one, certainly the problem we looked at it was not on target. The nominal value was different from the process mean. The nominal value was 0.225 and the process mean was 0.22. That's why you can clearly see the rejects on the left side and the right side. Rejects being oversized and undersized were different, right? There are multiple. Now you saw that one. Smaller areas we rejected being oversized, larger because of undersized, correct? And some CP guys will tell, CPK people will tell you, my CP of the process is the bigger one. If you take the lower one, which is a lot of rejects, you are doing injustice to your process. You are in different words, you are saying half glass empty. And worse than that, you're bringing your process way down by saying your CPK value is equal based on lower side in this example. And if you take the other one, you're overselling. You're not producing that level, and you're saying you're exaggerating the CP of your process. So you have to take both into account, and that we will talk way later. Okay, that should be okay. Boom, boom, boom. Okay, Mike, are we on for 8? Right?
Yeah, I think so.
Okay, good. I got solid, lot of time. Find the length of the shortest ladder. That's easy. Shortest ladder, and I'm going to work with this piece so that everyone sees this one. Thank you, gentlemen. You hope you got some idea about whose is this? Yours is right. This is yours, right?
Oh, yeah.
Thank you. This is a very straightforward one. You should be able to, all of you should be able to do it. Go pull out some notes, write down. It's much better that if you have it. Lucky me, I can see that guy. I can see it here. You won't be, so I'll leave it for some more time. And what do I have? I'm saying that there is a fence. Find the length of the shortest ladder that will reach over a 10 feet tall fence to a window 18 feet above the ground. The window is on a wall 4 feet behind the fence. Okay? Got some rough idea? So we'll keep that in mind and go to this thing. We are saying this is our ground. This is our fence. All right? And this is our house. All right? And that's our window. How about that? Okay? And I mean, it's not to the ground, not a good scale. I should go closer. I'll get rid of that guy. I'll go here. This is 10 feet. So this 18 feet is this guy. That's my wall. That's my house, okay? That's my window. That's my W. And this is 18 feet above the ground. Forget about that. This is 18 feet above, this is another partition. This is 18 feet above the ground. This is 10 feet. And this distance between this is another wall. How about put a wall here? They put a wall here. That's a wall. Between the two fence and the wall, the distance is equal to 4 feet. 4 feet. The distance between the wall and the fence is 4 feet. The window is 18 feet above and the fence is 10 feet. What do I want to do? I wish another color. I need to get one. Here. That's okay. I have to put a ladder to the ground. This is my ladder to the ground. So in simple words, gentlemen, ladies, this is 18 feet. This is my ground. And let's call this guy as 4 feet, 10 feet. What is the length of my ladder? Easily I can get it. Come back here. This is still 4 feet, not to scale. This is 8 feet, and this will be 10 feet. Correct? Sorry, inches I'm putting. 18 feet, one stroke. All right? 10 feet, 8 feet, 4 feet, 4 feet, 10 feet. Okay? So I know this is 4, this is 8. Therefore, I can easily know this angle here, theta. Correct? Okay? I can take tangent theta is equal to 4 over 8. Therefore, theta is equal to how much? 4 over 8 is tangent theta, and theta is equal to how much? Go ahead, use your calculator and let me know. Anyone? What's the value of theta? Take 4 divided by 8 is 0.5, tangent inverse 0.5. I know it, 30 degrees. 30 or 6? Half. Half is 1060. Hold on, 1060 is root 3 over 2. And sine 60 is Sine 60, no, 30, sine 30 is half, 3 or 12, no, sine 45, no, I don't know. Okay, what's the value of theta? So your value of theta is what? Theta is equal to, I know some of you are finding and feeling shy. Go ahead and tell me, 26.66? 56 degrees. Do you have a second on this?
Yes.
Okay, theta is this much. So I need to know this length. How would I know that length? If this is 18, this is unknown, I can apply what? In a triangle, this is 26.56, this is 18, I don't know this. What relationship would I apply? We talked about a little bit of trigonometry last time. This is adjacent, this is hypotenuse, therefore this angle relationship is what? Cosine 26.56 is equal to 18 divided by ladder L. All right? If that's the case, I'm not visible. Cosine 26.56 is equal to 18 divided by adjacent divided by the length of the ladder. Cosine is adjacent over hypotenuse. Adjacent is this one, hypotenuse is this one, which happens to be the ladder. That's too big, that's why it's causing that. This should be much better now. Okay, all right. So L will be equal to 18 divided by cosine 26.56. What will that be? What will be that?
20.12.
How much?
Is it 20.12?
25.12?
Or 20?
20.1? Okay. 201, go back. 0.1 happens to be one of those. A. This is the level of questions you can expect. Some of those we saw before may have been a little tougher, but so don't give up hope. There's a lot here. You can. My hope is that you should not make one mistake in the math portion. Everyone should come out very clean. So that's why we're jumping a lot more. So your math should be straight, clean. Okay. 12. Let's go here. Find the relative maximum and minimum points for the following equation. Like I said, I told in the beginning, today we are going to jump 8 feet, which means you're not only able to get T, but E. And again, I'm not building up your hopes. As I promised at the beginning, I'm not covering the E portion, only the T portion. I guarantee you at the end of 6-7 weeks you're done. And if you feel confident, we can give more and we can get you E also. But this will cover E. 2x cubed, 3x squared plus 4. General thing I want to talk today in terms of maximum minima. It's a nice concept. I tell my students many a time that here is a piece of paper, or here is a sheet of paper. All right, gentlemen, I have a sheet of paper. I want you to go make me a container. Make me a container that holds the maximum volume. I don't care what shape you give me. This is a sheet of paper. Make me a container, and they start scribbling and saying, how do I do it? If I would know basic concepts of optimization, I would have not much difficulty at all making use of this paper or making use of this surface area. I can cut whatever way I want. I can create a container that can hold the maximum volume in it. Maximum volume in it. So there are basic rules for optimization. You have all learnt it, but I understand it has been long. So you take a function fx, that's like a function fx is there. Let's not worry what is on the right side of this one. When you derivate a function, set it equal to 0, you got its extremal value. When you derivate a function and set it equal to 0, you got its extremal value. What is the meaning of extremal value? It could be a maximum or a minimum, but I don't know whether it's maximum or minimum. To know whether it's a maximum or a minimum, I will derivate this function one more time, the second derivative of the function, which will go through this on the board. Okay? I'll go to the second derivative of the function. Okay? And then what? If the second derivative is positive, then it's a minimum. If the second derivative is negative, it's a maximum. To my luck, you may come across the second derivative is neither maximum nor a minimum. Then it is so-called saddle point. And what do I do at that time? I find the third derivative and I get a positive. Wow, that's a minimum. Is negative. Wow, that's a positive, that's a maximum. But to my luck, the third derivative is 0. I go and find the fourth derivative. I hope this time it's a number. And if it's positive, it's minimum. If it's negative, it's maximum. Okay? This is a very straight, simple question. Let's go to the overhead projector and I'm going to do the simple derivation. 2x cube is 3x squared. That's straightforward. Okay? So let's go and take a look at this one. I'm going to go into hopefully you wrote it down. Go ahead and write it down. Fx equal to 2x cubed plus 3x squared plus 4. Fx, in your notes, write it down. Fx equal to 2x cubed plus 3x squared plus 4. Plus 4. And then let's go to laptop. Okay. F prime x is going to be 2 times 3 times x square, all right, plus 3 times 2x1 plus 0. Derivative of this 4 is going to be 0 equal to 0. That leaves me 6x squared plus 6x equal to 0. In other words, it tells me 6x times x plus 1 equal to 0. All right. 6 cannot be 0. I know that. Or x is equal to minus 1. All right. Okay. Let's go look at f double prime x is going to be, I'm going to take this equation, 6 times 2 times x plus 6. Okay. At x is equal to 0, there are two options I have. At x is equal to 0, f double prime x equal to f double prime 0 equal to 6, correct? So at x is equal to 0, it is at x is equal to 0, it is minimum. Okay. And look at x is equal to minus 1. At x is equal to minus 1, f double prime x equal to f double prime minus 1 equal to, what do I have? 12x, so this is basically 12 times minus plus 6 is equal to minus 6. It's a negative. That means it's a maximum at x is equal to minus 1. Fx is maximum and at x is equal to 0, at x is equal to 0, fx is, I hope you are not getting discouraged. I know we want to pass the exam, I made the statement before, but we'll learn a little bit more. Today was the highest peak, and then we'll come down. So bear with me, settle down, don't worry. We'll conquer this beast. We're going to conquer this. We should not have any difficulty getting through at least the first portion of it. Not all problems are straightforward or that easy, but so what do I see here? So what do I get here? Let's go back and see what were my options. We said on my this thing I said x is equal to 0, it's minimum, and minimum x is equal to 0. There are a couple of these guys. So minimum at x is equal to 0 is not minimum at 2 or minus 2, out of the question. So A and B, C and D are out. I said at x is equal to 0, it's minimum. I also said at x is equal to minus 1, it's maximum. Maximum at x is equal to minus 1 plus, this is the one. So the answer is A. We calculated minimum at x is equal to 0. These were our two options. We go back and look at our maximum. We calculated maximum at x is equal to minus 1. Therefore, our answer is A. Therefore, our answer is A. Okay. I have been talking. Please, you will do me a favor. Get up for 3 minutes. I'm not going to give you a long one. And go see if your snacks are good. If not, let me know, and I'll ask the sponsor to get something good next time. Please, all of you. I have a few more questions, and I want to kill this bird today and never talk about math. How about that? I'm not going to talk about math after today. We have a lot more chapters, but we'll at least, my hope was, whatever exam you take, this should be more than enough. It looks like I lost one of my precious students. I hope she's feeling okay or did not.
She said I can't.
Okay. I'll see her next week, right?
Yes.
Good. You work together?
Yes.
In the same area? Good.
Good, how are you? Party animal. You're an angel. You're an angel. Is that what it is?
I don't know what you're talking about. What is that?
Yup. drove into town.
I'm good.
You could.
Yeah.
Devendra, you don't wanna take a break?
Somebody pulled out and backed right in there. That was nice. Pizza next time?
For you, Dan, we can make that happen.
Pizza, Jimmy John's.
You bet.
Come on. Are we ready? Yes, no?
Yes.
Yes.
Good, 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 good. Good, 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 good.
My pizza dog is a day leaver, see her real quick.
Good. Good, good, let's go, yeah. Hey, guess what, I thought, gentlemen, ladies, I thought, my destination is far. It's not far, we'll be very soon done, so the pain is almost about to be over, right? One more little tiny pain and then we'll be done, or almost done, let's call it. I want to find the area between 4x square and 2x square plus 2. Find the area between 4x square and 2x square plus 2 from x is equal to 0 to x is equal to 2. Straight. All I want you to write down in your notes is 4x square and 2x square plus 2. The rest, I'll take care of it. Once you're done, I'm gonna flip this and go to the document reader, and I'm gonna do it. So you can relax, you don't have to worry about it, just relax, and I will compute it. Okay, it looks like most of you have written it down, x square plus 2x square plus 2. Let's go to document reader, and hopefully it's coming up. And what I'm gonna do is that area of 4x square between 0 to 2 is how much? And then I'm gonna do the same thing with the other one. This is going to be what? 4x cube over 3, correct? Integration of x square is x cube over 3 between the 0 to 2. So when I substitute upper limit, I get 4 times 2 to the power of 3 divided by 3 minus 4 times 0 divided by 3. Okay? This guy is going to give me 0. I just put it there. And this is going to be 8, 32 over 3. I'll leave it as it is. I don't want to worry about the fraction now. 32 over 3. Same thing, 0 to 2, 2x square plus 2 dx here, sorry, dx. When I integrate this, I'm going to get 2x cube over 3 plus 2x whole under the limits of 0 to 2. So when I get 4 terms. When I substitute the first one, 2 to the power of 3 divided by 3 minus 0. I'm not going to pull the whole, this thing is 0. Second one is plus 2 times 2 minus 0. This is going to give me 16 over 3 plus 4. That's going to give me 28 over 3. That's going to give me 28 over 3. Okay? Now I got two areas. He asked me, what did he ask me? He asked me he asked me find the area between these two curves. Then what are those curves are? Between them. So that would be what? That would be 32 over 3 minus 28 over 3. What could be simpler than this? 4 over 3, 1 1/3. 1 1/3. 1 1/3. So this integration portion is not that tight, and this is the maximum you can expect from this exam. Okay. Now I want you to find me some answers very soon. Okay, I'm getting to that point, but we saw this one, right? Let's go back and take a look at what did he give us. He gave us the following. He gave us this question. And this question tells me A is equal to 0, B is equal to 2 2/3, C is equal to 1, D is equal to 1 1/3. Wow, 1 1/3. Okay. Next thing is I want you to see, this is a real test for you guys. I want you to treat this as a test, and I want you to raise your hand if you're done. I'll give you 2 minutes. If not, we will do it together. How about that? Okay? Let's go. Oh, I was not visible? Okay, good. Let's go and solve this one. Whatever method you want to use is fine with me. Anybody has a destination already reached? 1, 2, 3, 4, all right. What do you have, gentlemen? Let's go back here. Let's go back. Oh, yeah, no, I don't have to, it's this one. So, anyone, it's your chance, go, tell me what you have.
C, D,
Which one?
D.
Charlie, Boy, Alfred, David. Who and how? What do you have? B like in boy, C like in Charlie, what do you have? Charlie? How did you get it? By
To be
what?
honest with you,
Uh-huh.
I just plugged them numbers into one of those equations and I got it right away.
You got it right away. Someone who tried to go it long way. I think Michael was trying to go. Are you still working?
Had to try it. Yeah, I was about there.
Almost there.
I got the Z right.
You got zeros? Yes. I got a lot of zeros here. Lot of zeros. Come on. Still working. Okay. You don't need to. Truly. How did it go? Let's look at this one. Let's look at logic on this one. I'm looking at what are my options, and sometimes he tries to be smart, but he's not. He gives me right away all my z's are 4. The first observation that came to me was 4. Okay, I have to have 4, and I look at this equation. This guy has to be minus 4. And I said, this is the easiest one. 27, this did not attract me at all. So I saw this as the smallest equation. Why did I go to this one? Because this seems to be the simplest of all 3 equations. Now looking at this, with this piece of information, this has to be 4. I said if z has to be 4, minus 4, boom. I got this one, somehow I have to get these 2 guys out of the window. I have to throw this and this. And I looked at an option, and I also know that y is half of x, or x is twice y. So I'm looking at x is equal to 2, y is equal to 1 ratio. And right away I see x is equal to 2, various options. And I want to get rid of them, so I look at minus 2, 1. This is going to give me minus 2 plus 1. Y is equal to plus 1. And what does it give me? That gets it out, right? Why this one? Why not this one? Tell me. If I look at this one, this will get me out minus 2, this will be plus 2, 0, and I still have z is equal to 4. So this is my one option. I don't know which one you tried.
It won't work on the other ones.
It won't work in the other one. So there's a little twist there. So there's a little smart piece here. So you might fall as C and D as my options. Right away, it took 30-40 seconds to get to this, 30 seconds to get very quickly. This is 4, and this is the easiest equation. Boom, I knew that this is twice this thing. Therefore, I'm looking x is equal to 2, and 1 has to be plus, 1 has to be minus. And I say these are my options. This won't work on the other. Therefore, C is the one. You can go a long way, or you can also use elimination. This one, multiply this with minus 2, get rid of x from here, and then get rid of y. Finally, you substitute the third one. You will get 1 question in the exam maximum. So just plug, not 1 equation, but preferably 2. If I were to do 1, this would mislead me. So he will do a little testing. Okay, next one. Okay, gentlemen, very important. Let's see if you can calculate this. Some questions made up this one. You don't find 3.456, but I'm trying to see what you can do. A portion of machine shaft has a taper of 3.456 inches per foot. What is the equivalent included angle of the taper? included angle of the taper. No brainer if you pay attention, otherwise it'll try to catch you a little bit. Got it? See what you have? Still working? Tick, 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 tick. Yeah, ready? Come on. 3.456 or 1 foot. Think. Think. This time. Read that.
Oh, you did.
Yeah. Surrender. What's your answer, Chief? Right. Right.
Yeah, I can,
Write the number. Write the number. I know I can.
okay. No, okay.
Right or wrong. Read the question. Okay, guys, enough. He's trying to play a little hard here. He's just trying to play hard. It's such a short sentence, but he's trying to play hard. What is he telling us? What is the equivalent included angle? Right. This is straight, no problem here. So this is what's the little catch we're trying to play here. And this is 3.456. Let's make it bigger. This is 12. And this is the angle. Included angle. This is a taper, right? A portion of the machine shaft has a taper of 3.4 taper.
Taper's measured over diameter, though, not radius, right?
Taper over diameter. That's a good point. Is it 16 or 32? I'm thinking it's 32. Included angle. You have to double check on that. Is that what? Over diameter? Are you sure? Usually, from a pure name point of view, included angle, I'm looking at 32. Unless you tell me maybe some convention. Mike? Can anyone clarify on that? My tribal knowledge tells me it is, included angle is, twice of that what I'm calculating. So I'm thinking the right one is 32. Okay. Anyone feels uncomfortable on that? So the taper is, this is geometry. I would still feel, the more I talk, I still feel 32 should be the one because it's the taper is going at the distance I'm traveling here, it's going that way. So I put two the total, and that's why here I put the word also included. I think I'll still feel 32 is the right one. Okay.
Go back.
I know, 32. Law of cosines describes what? Law of cosines describes what? Relationship between law of cosines describes the relationship between. We'll double check. My self feel the included angle is 32. A, B, C, D. No calculations here. We talked about it last time. Which one is true? One side of a triangle and an angle, three sides of a triangle and an angle, two sides of a triangle, one side and two angles. Which one? Which one? B? Yep. B. Boy, what do we have there? Three sides of a triangle and an angle. AC square, if I have, we said basically this ABC, AB square, BC square, AB square plus BC square minus 2AB BC cosine theta is equal to AC square. So we are talking about all three sides and one angle. Shall we move from here? I want to cover at least 10 minutes the next portion. This is something that you must, where are your books? Something you have to write down in your books. I don't think I have to allow you in your exam to loose leaflets, but your booklet is, nobody is disallowing you. So write this one. It's not a, when I take 1 cubic inch and convert to gallons, he's asking me how many gallons of water will this barrel hold. The barrel is 16-inch diameter, 32 inches. This one, those of you who have your book with you, can you go back and tell me you have a conversion there? If not, I'll make you write this down someplace, and this is very important. Remember only one thing, and that's it. Because there is a US gallon liquid, there is a US gallon dry. There is a US gallon liquid and a US gallon dry, and there is a UK gallon liquid. So you could make 3 different things, and he could calculate on the basis of those 3 and try to trick you. And you will think each one of them is correct one. quotient table? We are not talking about US gallon dry, we are not talking about UK gallon, okay? So let me give you that one, then the rest is history. 231 cubic inches, 231 cubic inches is equal to 1 US liquid gallon. So in the milk bottle, if you buy gallon of milk, it has 231 cubes of 1 inch in size. 231. Okay. All right. These numbers are pretty close. Let's see what you get. 231 multiplied by pi d square, pi times 16 square over 4 times 32. Pi times 16 square over 4 times 32. 16 and 32, write it down, and I want to take a 5 minute for something else, but I have, I'm going to give you 1 more minute to okay, very quickly. Okay. Good. Ready? Norman, what do you have? I'm going to expose that. Do you have an answer? You have an answer.
C.
A, B, C, D. Which one?
C.
Huh?
C.
Charlie? Charlie? Yep, Charlie. Absolutely.
If we answered C on all the stuff that you showed tonight, we would have passed the test.
Relax. Close off here. Relax now. All right. I want you to. I want you to.
Probably better than that, probably get 70%.
Yeah. Moment. Real quick. Remember you saw this slide. We are done with math for good. Everything is done. You can jump 8 feet. All you need is 4 for T and 5 for E, and you have jumped 8 feet. If you can get that 14, 15 problems we solved today in math, it took a little time. That should cover up everything. Okay, applied science, good and bad. It's very huge. So I'm gonna go to this guy. In this one, I have units of measure, light, sound, electricity, statics, dynamics, blah, blah, blah stuff. I'm gonna finish in 5 minutes chapter 2. How about that? Chapter 1 took a long time, all right? I'm gonna take 5 minutes, finish chapter 2. So for chapter 2, here we go. Chapter 2 is, it should be 2, not 12. Okay, part 2, chapter 2, units of measure. What are units of measure? International and US customary units. Sometimes people ask me, why do you call it SI units? I say SI means international standard. And why don't you say IS instead of SI? French usually go opposite, you know that, right? So we had a test in TCK called COM test. COM test is a French test called coupon, outil, and métier. Outil is the tool, métier is the metal. It's a couple. In America, you would say tool and workpiece will interact. guys will say interaction, tool and workpiece. So the contest was basically Kupul, Otil, Meteor. And so that is the international standard that is in Paris, US customary units. I want you to know is FPS system. The fundamental units here are FPS, foot, pound, second, meter, kg, second. Time units are same for both second and second. Very quickly, I want you to know something that on this part, real quick, F, how about, make a neat one, FPS, this is a unit of foot is length, alright, pound is the unit of force, second is a unit of time. Therefore, mass is a derived unit. Mass is a derived unit in FPS system. In MKS system, M is meter, which is length, K is kg, which is mass, S is second, time. Who's left? Force is a derived unit. Length is in meters, I can remember. Mass is in kg, I can remember. Time is in second, I can remember. Force is in what? Newtons, I can remember. Who can tell me foot, length, pounds, force? Great, I can remember. Second, time, I can remember. Mass units in FPS system are called what? This is newtons. And 1 Newton is what? 1 Newton is equal to 1 kg meter per second square. What about mass units? What are mass units called? Leave alone the units of it. Just tell me what are they called. Very difficult to remember. Slugs. What are the units of slugs? I'll give you a simple recipe. You can't forget this at all. F is equal to ma. Works for both. M is equal to F over A. F is in pounds, feet per second square. LB second square per feet are the units of flux. Who's going to remember this? Remember F is equal to ma. That'll take care of every, that's a one medicine for all diseases. F is equal to ma will take care of lot. Let's move on to this side. Okay, I'm going to give a little bigger one. Don't worry too many of these things. Length is in meters, mass is in kg, time is in seconds, electric amperage in amps, temperature, absolute temperature in Kelvin, amount of substance is mole, luminous intensity CD, meter kg second. If you remember, that's enough. The rest of it is not that much.
Isn't it Celsius?
Say it again.
Isn't it Celsius?
No, we are in SI system. Oh, good question. Is it Celsius? Where is Celsius? The British system. This is a standard system. Kelvin. Okay. SI prefixes. Tera, giga, mega, kilo, hecto, deco, and deci and so on. Most of it you're familiar with it, right? Pico, 10 power minus 12, femto minus 15, and atto 18. Nice to keep in mind. Atto 18. Okay. Express 207 times 10 power 3 megapascals as pascals. Mega means 10 power 6. 10 power 3 times 10 power 6 is 10 power 9. 207, 10 power 9. Generally, this is you're looking at modulus of elasticity range or so on. Okay, straight. That gives me very little time and I'll be done. SI derived units, various derived units are there. Don't have to go through all of them. One more example, convert 1.25 inches to millimeters. Few things to remember. 1 inch is equal to 25.4. That's it. Nothing more than that. 1 inch is equal to 25.4. So, and we also know 100 millimeters make 1 meter. Huh? 1000 millimeters make a meter. 100 centimeters make a meter. So you have, if I want to convert that, basically I take 25.4 divided by 1000, that becomes 0.0254 meters over 1 inch. That will give you the value of meters. Okay. Don't have to go through this one. You can reverse engineer it. You get this number. Don't have to memorize this. All I want you to keep in mind is 25.4. 1 inch is equal to 25.4, and you can do the reverse. US customary systems. We already talked foot, slug, seconds, ampere, mole, Rankine, not Celsius, but we use common Fahrenheit, this thing, Rankine for temperature. All right, customary system conversions and so on, forget it. That's it. I don't want to take you more than that. I have lots of problems. I will cover those problems, but yeah. Well, I might do a little bit of theory when you come back and get into problems from questions from science fiction. Sorry if I taxed you too much today, and hopefully it won't be that much of a pain going forward. Also. Thank you for your patience. I hope another best are waiting outside, so partners, please, where are they? You are ready for me?
Get back to water.
Oh, right, I know they were recording. I know you might be. Yeah, Mr. Adam, you might be being recorded. Who knows?
How are you?
I think they may be recording, so Adam. Be careful.
Yeah, I don't want to say
Yeah, you
anything
better be careful now.
incriminating.
You behave. They were all laughing last time. They were all laughing. This is all yours. Oh, good. There were calculators. Return me back, please, if you don't mind. I'm gonna. Adam, can I log out?
Yeah.
Sure.
Well,
Well,
actually, just stay on. Stay on. Stay on.
Log off, basically. You're gonna be on. Okay, all yours.
We're gonna talk to you first.
yeah.
Who's gonna
Is it
talk to
all
you first?
caps or is it
They
just
are.
C?
Wow, see,
Just
Who?
C?
great.
Okay.
Who's they?
What?
They're gonna talk to you about our grade real quick while I log in. Yeah, we're gonna break it to you. Make sure you're ready to listen.
So, by the way, guys, can we sit in a team? I'd like to get closer. I'm not gonna show like last time. My throat was wrong. I want to have a team. Come.
Do you want me to log on?
Let's have a team meeting quick and then we can go.
So we got our Fisher grade sheet back for our proposal. Yeah, we got about 56%. Yeah, so 27.5 out of 50.
17 plus enough.
And so we have till
You
2
do
o'clock.
everybody or you?
She said everybody.
Everybody got grades too? And wasn't that, how much is the adjustment like that?
It is better. I don't know.
Yeah, they got like 85% or something. It was 83 something on there.
You win some bad?
Yeah, very bad. Yeah. We have till,
Is it gonna count in the cumulative or?
No, I just keep hearing.
so this one, so we got 27 points on this one.
Uh-huh.
And then if we revise it and turn it in, we can get a maximum of another 50. Then she adds them up to the total. So best case, we could get a, best case, we can get a 77%.
27, oh.
Yeah.
Yeah,
So the best case scenario you want to see.
on our proposal.
And then how many times do you go through the process?
That's the last time.
You only get to revise it once.
Proposal, then how many, what?
Well, I
Proposal.
assume
Like
it's-
I give 7 tests, 5 quizzes,
I
1
assume-
midterm.
You have
one
proposal and technical
It's gonna be
report.
stage 1, stage 2, stage 3.
Stage 4, so this is stage 1.
This is stage 2, but we
So
don't turn in
proposal
the
is stage
proposal
1.
every time.
Stage,
get 70 the first time, second time I have to go to 80, third time 80, 90, 95, 100, and then 1 year I will go. Right?
I mean,
Yeah.
yes, the average will
Are you
go
finished
up,
with
but
the
it's
last
not
one?
going
Sweet.
to, I think so,
Alright.
like, our grade will still be low. Like,
I understand, because you're giving me some, you're not telling me this is how much, is this a middown and no other thing, I can see, yeah, that's it.
No, we'll be fine, this is just a shock treatment, cause we had everything good.
but that basically means we can't have anything else go
Yeah, we
like
can't have